Lesson 2-5, Limits Involving Infinity. Find the limits of functions where either x becomes infinite or the limit is infinite. Let's take a look at this example. Suppose the demand for doctors in a particular community has increased. So we increase the number of doctors, and there's too many doctors, so less doctors go into the profession, and then again we don't have enough doctors, and then we increase until we level off. So this is an example where as time goes to infinity, it looks like we are getting closer and closer to stabilizing at about 1,000. Let's take a look at another example. If you were to take a flashlight and point it to the wall and then turn or make your X, the angle, bigger and bigger, you can see that the length of the beam is getting longer and longer. So as we get as our angle increases from 0 to pi halves being 90 degrees, the length of the beam becomes more infinite. So this is an example where x is approaching a particular number, but the limit is going to infinity. All right, let's take a look at a model. This is our graphical model, and you can see as x approaches 2 from the right-hand side, so as x approaches 2 from the right-hand side, we're getting closer and closer to the number 2 here, that our y values are getting larger and larger. And if we approach from the other direction, so as x gets close to 2 from the left-hand side, so again we're getting closer and closer to 2 here, you can see the y values are becoming more and more infinite in the negative direction. Now we say this, we say the limit as x approaches 2 from the right-hand side of f of x is equal to infinity. Now we still have a limit that does not exist, but we prefer to write infinity to tell us why it's not existing. And there's some cautions about how to use the infinite symbol. We don't want to write f of 2 is equal to infinity, but we are allowed to use it in a limit situation. All right, let's take a look as x approaches negative infinity and positive infinity. So here as x approaches negative infinity, it looks like it's getting closer and closer to the number 3. So we get bigger and bigger, smaller and smaller values, we're getting closer and closer to the number 3. So we say as x approaches negative infinity of f of x, we get close to the number 3. And the same thing is happening over here. As x approaches infinity, as we get larger and larger values, we're getting closer and closer to the number 3. And so here's how we write. Again, the infinity symbol is used only in conjunction with limits. All right, so here's some definitions utilizing infinity. So we say when x approaches some c value, whether on the left-hand side or the right-hand side, positive or negative, from the negative direction or the left direction, we say that that limit is infinite if and only if, and again this is a definition, f of x can be kept arbitrarily far away. So the closer you get to 2, the farther and farther we get away from the 0 here. As x approaches infinity in this direction or negative infinity, and we approach a limit, we say if and only if f of x can be made to stay arbitrarily close to the limit, we're staying close to the limit just by making x large enough. So we can go far enough out here, we'll be close enough to our limit. And our last definition is if x goes to infinity and our value of f of x goes to infinity, where both of them are going to infinity, and this situation can happen like with a parabola. As x gets larger, the value of the function gets large without bound. Okay, and now we have horizontal and vertical asymptotes being defined by a limit. So we can say something is horizontal or vertical in these kind of situations. As x approaches infinity, as you get larger and larger x values and we're getting closer and closer to a value, we say this is a horizontal asymptote. If x gets closer and closer to a particular c and the y values are going to infinity or negative infinity, we say we have a vertical asymptote. Okay, let's try to understand the definition a little better by going ahead and looking at some numbers here. Now, here is the graph right here of this particular function that I have over here as well. And we want to find what value x greater than 2 makes f of x equal to 500. Okay, so as we get close to 2 from the right hand side right here, so we're going to let f of x equal to 500, and we're going to set this equal to the function. And when we solve for the function, we're going to get x is equal to 2.002012. So if we get that close to x, we know we'll be at 500. And any values closer than that will even be higher values. So if I were to make a chart, x and f of x, and if I were to get a closer value like 2.002, which is closer to 2 than before, my f of x would be 503. If it got even closer, my value would be even higher. And if I got even closer than that, I'd be even higher. So what this is saying is, the closer I get to 2, the farther and farther I'm away, and I'm even going past my 500. Now let's take a look at what do we mean when x is greater than 2. What makes f of x equal to 3.004? So I'm going to write 3.004 equal to 1 over x minus 2 plus 3. And when I solve, I'm going to get x is equal to 252. So that tells me I have to be far, far out here. I have to be at 252 before my y value right here will be at 3.004. So you have to go far enough out in order to be that close. Let's take a look at a table again, and let's take a look at values of x's that are farther out. So if I let x be 260, this is how close I would be to the number 3, even closer than I was with the 0.004. And then 500, it would be 3.002008. So the farther out you go, the closer you are to your limit. And this is how we explain the definition of the limit. All right, let's take a look at this picture and see if you can find all these limits according to this picture. I'll give you a few minutes, stop the screencast, and then you'll see the answers. Here are the answers. So as x goes to infinity, we're getting closer and closer to the number 4. As we get closer to the number 3 on the left-hand side, it looks like we're getting close to the number 6. But from the right-hand side, we're getting close to the number 2. As x approaches 1 from the right-hand side, it looks like it's going to negative infinity. But if we approach 1 from the left-hand side, we're going to positive infinity. As x approaches 0 right here, there's no infinity involved, and we just say the answer is 4, and we say this is continuous. If we go to negative infinity, the y values get closer and closer to 2. So notes on undefined, infinite, and indeterminate. Make sure you read these things so that you can be familiar with what we say when we say infinite form or infinite discontinuity, and indeterminate form. And this is the end of the screencast.